So I got about 15 minutes here before classes start. May as well crank some of this out. This is your twin for Friday's test. First up, write two polynomials equivalent to 9x squared minus 36. So what I'm looking here for is one that you can factor, which would be 3x minus 6 times 3x plus 6, by the way, because 3x times 3x is 9x squared plus 18x minus 18x and then minus 36. And you can think about different ways of potentially factoring. Or you could pull the 9 and make this look like x squared minus 4. Because 36 divided by 9 is 4, kids. Which would factor as 9 times x minus 2 times x plus 2. So there's your two equivalents that I'd be looking for on a problem like that. All right, number 2, express 12 cubed plus 6 cubed using a cubed plus b cubed. So what you have here is a, which is 12, and b, which is 6. And you're not supposed to do anything else other than just plug it in. It's 12 plus 6. This would be 12 squared minus a times b, 12 times 6, and then plus b, which is 6, squared. Like, wow, it's that easy. Really, really easy. Now, I might do a minus on the quiz. I might do a cubed minus b cubed. All right, write two polynomials equivalent to 8x cubed minus 216 using the a cubed minus b cubed pattern. So and it is a right two, by the way. So, one of these things we might do is we might look at this and think that that's a 2x that's cubed and 216. That's a 6. A 6 that's cubed. So a is going to be 2x and b is going to be 6. So let's just plug in my little formula here. A minus b, 2x minus 6. A squared, if you square a 2x, remember it's 2x all squared, you get 4x squared, plus ab, 2x times 6 is 12x, plus 6 squared, 36. So there's one of them I'm looking for. Now, when I look at the numbers here, I actually see something that is also divisible by 8. I can pull an 8 from everything. And how many times is 8 enter 216? 27 times 27. So I can pull a number and I can make it smaller. If I do it this way, I do thinking that I have an x that's cubed, take away a 3 that's cubed. So a is x and b is 3, not negative 3, just 3. And that one would factor as 8 out front. It's going to be there, all right? X minus 3. You square an x, you just get x squared, plus x times 3, 3x, plus a 3 that's squared, which is 9. So there's the two that are equivalent. It's not necessarily hard, but it's factoring. I know how y'all feel about factoring. It is what it is, though, kids. Learn that. Learn to understand it is what it is. So here's another one of those right to equivalent to. This is 4 terms. This is definitely going to be a factor by grouping. And I bet it's got a lot of factoring within factoring within factoring on it. So I'm going to look at the first two, and it looks like I can pull an x squared. And if I do that, I'd have x squared minus 16 remaining. And I'm going to look at the back two, and it looks like I can pull a negative 4. If I pull a negative 4 from a negative 4x squared, I have x squared. If I pull it from positive 64, I have minus 16. So there could be lots of potential answers on here, but one of them would be my next line, which is x squared minus 16, which the board would keep up with me, times the stuff left over, x squared minus 4. So that's a good place to be. Now, it turns out that both of those things actually still factor. X squared minus 16 is x minus 4 times x plus 4. And then x squared minus 4 is x minus 2 times x plus 2. Those are probably the ones I'm looking for. Not necessarily a difficult problem, but it just depends on how good you are at factoring now, doesn't it? Number 5, use synthetic division or remainder theorem for that matter. Determine if x minus 2 is a factor of f of x equals x cubed plus x squared minus 6. This says something about state. State what? State why or why not? Okay. I'm just going to use synthetic division. let's see, I have x minus 2, which means that x is 2. Change signs. Coefficients are 1, 1, and notice there's no x. 0, negative 6. Now we're going to drop, and we're going to multiply and add. We drop the 1, 2 times 1 is 2. 1 times 1 plus 2 is 3. 2 times 3 is 6. 0 plus 6 is 6. 2 times 6 is 12. 6. Remainder constant xx squared. Now, x minus 2 is not a factor because the remainder is not 0. It was 6. You have to have a 0. We've been over that repetitively. All right, simplify using long division. Your last quiz, the long division, no bueno. No bueno. Maybe it'll be a little better this time. I don't know. I'm going to put in placeholders just because I might need them there. That was one of the things I noticed on your last quiz. You guys are very bad at lining up like things. You know, I've been teaching Emmett how to do some basic math, the old math algorithm. And if my 7-year-old can line up, singles, tens, and hundreds places, by God, a junior ought to be able to line up x's with x's. You ought to be able to. Let's see, the dividend is right there. The divisor, x squared plus 2x minus 1 on the outside. And the first goal is to think about what it takes to make an x squared be a 2x to the fourth. And I believe it takes a 2x squared. Then I use that distributive property. 2x squared times x squared is 2x to the fourth. 2x squared times 2x is plus 4x cubed. 2x squared times negative 1 is minus 2x squared. Remember, we wrap before we subtract. So the x to the fourths are gone. 0 take away 4 is negative 4x cubed. A negative take away a negative is addition. So there are no x squareds. We're going to bring down that x because we'll probably need her. Now, I want this piece to become that. I do that by using a negative 4x. Yeah, that'll do it. Negative 4x times x squared is negative 4x cubed. Negative 4x times 2x is going to be, lost my place here, negative 8x squared. By the way, there were 0x squareds left here. And a negative 4x times a negative 1 is plus 4x. And again, wrap before we subtract. So the x cubes are gone. 0 take away a negative 8 is 8x squared. And then we have x take away 4 minus 3x. And then we're going to bring down that negative 4. And we got one more move and we're done. I need to multiply this x squared by 8. And here's a positive 8. 8x squared plus 16x minus 8. Wrap before you subtract. A negative 3 minus 16 is negative 19x. A negative 4 minus negative 8 is plus 4. And this is my remainder. So my answer here is the quotient 2x squared minus 4x plus 8 plus a negative 19 pieces of x plus 4 over x squared plus 2x minus 1. Check this out. I don't know if I should show you this or not, but you're watching. I'm going to type in the original function here. We go to math, num, n over d. Because that's the way you should do it. Lost everything. We got 2x to the fourth. This is how I'm going to check my work, okay? I'm going to check it. Maybe you'll catch on to what I'm trying to show you. But it occurs to me that if my work is correct, then the graph of my answer here should match the graph of the original function. Of course, the original function is a rational function. It's going to be a hideous looking thing. No, that's tiny on your screen. Don't worry, I'll make it bigger in just a minute. What did I come up with? I came up with 2x to the second minus 4x plus 8 and then I had a remainder, so plus, gotta use parentheses here. Or I guess I could do math num n over d. Do that. Math num n over d negative 19x plus 4. This will tell me if I'm right or not. And that was sitting over x squared plus 2x minus 1. So if my work is correct, these graphs are identical. Which, by the way, is just a great way if I make this thing multiple choice. I don't know if I will or not. So let's see if I was right or not. And if I was wrong, I can go back and fix the mistake. So here comes the original. She's in blue. And Y2 would be red. If you hadn't figured that out, start paying attention. Unless you change your colors. Well, they are identical. So since they're identical, that means I did my work correct. Anyways, there's more to it than that. I just taught you a standardized test skill, by the way. All right, I got 5 minutes left, so I got time to do at least one more. List of potential rational zeros of g of x. So for some ax to the n, whoops, I wrote that wrong. Ax to the n plus ... a constant, your list of potential rational zeros is simple. It's factors of the constant over factors of a. So our constant here is 4. Our list would be the factors 4 being plus or minus 1, plus or minus 2, and plus or minus 4. This is C, by the way, and this is A. Factors of 9 would be plus or minus 1, plus or minus 3, and plus or minus 9. So what I'm going to do is I'm going to divide everything by 1. Anything divided by 1 is itself. Okay, now I'm going to divide everything by 3, plus or minus a third, plus or minus 2/3, plus or minus 4/3. And now I'm going to divide everything by 9, plus or minus a ninth, plus or minus 2/9, and then plus or minus 4/9. 3 minutes. Let's see if I can do one more. Probably not. So I don't have enough time for number 8. So this is where I'll start later. All right. Hope you enjoyed. See you in just a minute, first period.